What's up, everyone? My name is Dr. Chris Hacks, and welcome back to another CryptoPals Crypto Challenge. Today we're going to be implementing PKCS number 7 padding. So what is this? Well, let's read this. A block cipher transforms a fixed size block, usually 8 or 16 bytes, of plain text into ciphertext. We almost never want to transform a single block. We encrypt irregularly sized messages, like you might have a really long text file, and it's probably not going to be divisible by 16 if you were to count all the characters. So, one way we account for this is by padding. One of the most popular padding schemes is called PKCS number 7. So to pad any block to a specific block length, we will append the number of bytes. For instance, we have yellow submarine, and then padded to 20 bytes would just add that character. So what we would do, this right here is 16 characters. So we take 20 minus 16 and we pad 4. So 4, so we take the character for 4 in ASCII, which is going to be something random that's not printable. You can look it up in an ASCII table. And basically we just append that character to the end of the string 4 times in order to get this to be a block length of 20. So we're going to hop into our code and implement that. Okay, first things first, we need to actually set up set number 2. I'm going to go ahead and do that real quick. We are going to do new, so let's see here. Yeah, CryptoPals. Where is it? Add, here we are. Add a new filter, and we'll call this set 2. Okay, perfect. And then inside of here, we're going to add a new item. We will call it challenge, and this is challenge 9. All right, perfect. Okay, and then we can go ahead and set up all the other stuff as per usual. Haven't been doing it on video just because it does take a little bit of time. That's not super necessary, but I'll show you all today just because we're switching to a new set. So here we will have challenge 9. Copy this right here. Let's hop over to challenges.h, and here we go. Perfect. Okay, cool. So now we have challenge 9, and we can get this all set up. So let's jump back into our challenge9.cpp file, include challenges.h. Oh, spelled that wrong. Perfect. And then I will paste this here and start our function. All right, so we already know that our constant is going to be yellow submarine. So I'll make a constant string here, and let's just call it, we'll call this plain text. That's really what it is. And then we have to add our padding. So today we're going to make 2 different functions. So if I hop over here into encoding utils, we're going to make both pad and unpad. So let's do this. Let's do, I'll have a string, or I guess I need to go define these real quick. Let me do that real quick. So we'll go over here to our header file, and I'll call this pad, and we will do pad PKCS7. I believe that's the name of it. Let me just check. Make sure I set it up correctly. PKCS7. Perfect. Alright, so we'll have that. We'll take in a constant string called plaintext and a size t called block size. That way we know how much to pad. And then we could basically do the exact same thing, and we have unpad. We also don't need to take in the block size, because if it is padded correctly, we can detect that, because the last character is either going to be like a 1 or a 2, and then you remove 2, and you can detect it very easily. So we don't even need to take our block size in. We can just unpad it. Alright, perfect. Let me go ahead and copy these over to our coding utils, and I will go ahead and define them now. Okay, for the first one, for pad PKCS7, it's pretty easy. We're just going to need a couple of things. First, we're going to have to calculate our character. So what we can do to get that is to get the actual size of our text. So what we'll do is this. We're going to take the length of our plain text, basically. So let's do this. Int, and I'm going to call this final block length, and it's literally just going to be plain text dot length. And we do have to modulus this with the block size. So what this will give us, say for example the block size is 20, and we have yellow submarine. And let's say that there's a bunch of text before it, but yellow submarine's the last block of 20 characters, and we take the length, modulus by 20, and then we get 16. That would be the length of yellow submarine. Okay, and this should be actually, let me make this a size to you. So that will give us the final block length, and that is what we want. So we'll get 16. And what we can do with that is actually get our character from that. So we'll call this pad. And it's literally just going to be, well, first we need to check, is the final block length equal to 0? If it is, we don't want to pad 20 new characters. We just want to pad 0. So if it's equal to 0, we'll pad 0 characters. Otherwise, we're going to pad block size minus final block length. Okay, so we'll just do that. That way we can get the correct character. Now, next here what we'll do, we will actually make our string to output. I'm going to call this padded text. And it will literally just be our first string. Call it plain text dot begin. We'll get the start of that and the end of it. So we'll just create a new string, and then padded text dot append, and we will put pad comma. Pad. Yeah, because we're going to pad it. So if like pad is 4, then we're going to put 4 characters of ASCII character 4. Okay, and then we can just return it. Okay, and that's how we do the padding for PKCS 7. Pretty straightforward. Now let's get the unpadding going. So for this, we're more or less just going to be doing the opposite. We're going to be getting the last character, seeing what character it is, and then padding, undoing it, basically. So let's do that first. So first, char pad is equal to padded. I call this plain text. This should not be called plain text. This should be called like padded text. So let me take that, come back over here, call it by the right thing so that it keeps everything consistent. I'll make this, I guess I'm not putting text as capital. We'll keep it as one word, so we can keep it like that. All right, so we got padded text here. We'll take the char pad, and then we'll do padded text dot back, so we get the last character in it. And then what we want to check for is if it's greater than 0, or I'm sorry, if it's less than 0, then we'll just return padded block. Or padded text. The reason why we're going to do that is because if the pad is less than 0, it's probably invalid. Or if it is 0, then that means it's invalid. We shouldn't really be running into this. And then also we should probably do this as well. If padded text is empty, then we also want to return padded text, because that means that we're just returning a blank string. And then I guess theoretically we could also pass in the block size to make sure that this is not greater than the block size. However, we might not always have the block size when unpadding, so for now we're just going to assume that is this. But either way, we're just going to check for it right now. So watch this. The for size t equals padded block padded text dot length. What we'll do is we're just going to iterate through this. Oh, sorry, for size ti, and then minus pad. We're going to iterate through the last characters, and the reason why we're going to do that is we want to make sure that they're all the same. If they're not, then it's obviously invalid, because you have like the last character is the ASCII character 4, like 0x04, and then you go 4 characters and not all of them are 0x04, then obviously it's padded wrong, because all 4 characters at the end of the text should be the same and should be that character for that length. So we're just going to have a for loop to check for that. So we're going to go to the character that should be the first padded character, and then for I is less than padded block dot or padded text dot size or dot length. What we'll do is we will ensure that it's actually the correct length and it's all correct. So yeah, we'll just do if padded text of I is not equal to pad. So if it's not the right character, then we already know that we don't have the correct padding schema. We already know that the padding was incorrect somewhere. We passed in some invalid string, and we can just return the original string. You could also throw an error, technically, if you wanted to. I'm not going to do that. I'm just going to return the original string. But yeah. But anyways, once we verify that everything's actually correct, we can just return the padded text and then substring it. So substring 0, comma, padded text dot length minus the pad, because we verified here that we're actually getting the right characters, and we're verifying here that the last character is actually valid. And by doing this, we know that it's actually a valid PKCS 7 pad, and then we can just return it with all the substrings and everything. Okay, so now here's the next part. What we'll do next is I'm going to create a string, standard string, let's just call it padded text, keep everything simple, and then we're just going to, I need to include the header as well, include, call it encoding utils.h, and then we just do pad PKCS7, plain text, and then we have it as 20 bytes for the block size, and then we can return this. The only problem here is, though, ASCII character 4 in hex is not printable. So what's going to happen is we're just going to get our plain text back with some garbled junk. It's probably going to be new lines because we're doing 4. Let me check actually real quick. So ASCII table, I'm looking at it off to the side. Yeah, so the ASCII table says that character 4 is the end of transmission character. So that's not going to get padded here. So what we're going to do is we're going to create a function that actually will take printable characters, print those out, and then non-printable characters, and we will convert them into hex so that we can actually visually see them. So in order to do that, I'm just going to go into I'm going to actually do this in the challenges. Well, where do I want to do this? Because I can either do it here, so I'm going to actually do it in coding utils. I think this will be probably the best place to do it, just so it's accessible to everything. And it's still, this is technically an encoding util. So, yeah, here's what I'll do. I'm going to do this. This is going to be a string. Actually, this is including libraries that I don't necessarily need in every single file, so I will make a new header file for this. So we're going to do this called, I'm going to call this print utils. Yeah, that should probably be good. Print utils, blah, blah, blah. Okay. Or whoops, let's rename this. Print utils.h. That should probably be a good name for that. And what we'll do, so pragma once, spell it correctly. And then what we're going to need is a couple of printing libraries to help us out with this. So we'll use iomanip, include stream, and we're going to need iostream. I'll show you all why in a second. I'm going to have a standard string format. I'm going to make it, yeah. How do I want to call this? Let's call it format as printable. And all it will do is it will take in a string that we're going to want to basically take all the non-printable characters and make them printable. We'll have a string, and I'll just call it input. I'll keep it nice. Okay. Yeah, that should be good. That should be good. And I'll add down here print utils.cpp, and then hashtag include print.h. And then all we need to do is create an not a string, an O-string stream. Yeah, an output string stream. That's what we're doing. Hold on, print.h, does that need, oh, print utils, sorry. Yeah, not print utils. Okay, perfect. And then we're gonna call it this, just to keep it simple. But yeah, this will be it's an object specifically designed for creating a string stream that we output. So yeah, it just is a nice standard library object that we can use. All right, so we're gonna have an unsigned char-rc in our input, and for every single character, we're basically gonna check if is print. So if it's printable, then we're just gonna append it. So just use the append function. And then if it's not printable, then we will just convert to hex. So SS. So we could either call our hex function, but the standard library has some built-in stuff, so we're gonna end up using the built-in stuff, just because it's optimized for that. So we can use standard hex, and then we'll just do set with 2, and then, whoops, set fill with 0, not the ASCII number 0, the character 0, and then we're going to convert this to an integer. Perfect. And this will be optimized for standard library. You could, if you don't want to use standard library stuff, you could use our hex to text function from earlier, or text to hex. That also works. However, we'll just do it this way just to keep it all standardized for the standard library. And then we just return OSS to string, and that will format everything correctly. So now if I go back over here, I don't even need to worry about that. Okay, that's all good, that's all good. Here. I'm actually going to return, or I need to include the header. So hashtag include, we're going to include print utils.h. You can either do it here, or you can do it in the main function. I'm going to do it here because I want to keep the main function looking nice and pretty over here. So we're just going to return format as printable and padded text. So now, if we actually run this, we'll see everything gets padded correctly. Compiles everything. Yeah. Yellow submarine, 1, 2, 3, 4. Perfect. So it pads it correctly. Let's just make sure our unpad function works. So we know pad text is working. So let's do unpad PKCS 7. Okay. Now if we run this, we should get the original yellow submarine with no padding. As you see, we got that. So everything works as intended, which is perfect. Okay, so that's how you implement PKCS 7 padding. So thank you all for watching, and yeah, we'll take a look at this in the next episode. We're going to be using this padding to actually break encryption for one of the encryption function we implemented earlier, which was the electronic code book. We're going to be doing something else next. We're going to be doing a block cipher that's a little bit different in a minute. But for now, we will just be using this padding in order to set up for that. So thank you all for watching. Tune in next time for the next CryptoPals challenge, and I will see y'all in the next video.